All right, I think we are ready. Everything looks like it's going. This is our last talk, anyway. We do have one more event on Wednesday. We won't stream, but at noon, if you're around and able to and want to, that's when we will do the catapult contest. So, um, if you've done some other contest or if you've done a video of your catapult contest, then you don't have to come to the actual thing. You don't have to come to it at all. As long as you do a contest somewhere for the class, then you're all right. But what we'll do is at noon, we'll meet at IESB and do our little catapult contest out there. And we'll, anybody that's in person can compete, and we'll see who the winner is. I do have a couple of things that we can use as prizes. Nothing major, but some of the stuff that we used in class that I still have. So we'll do that. Today's really just let's go through and make sure everybody's got everything in line. I have a couple of little things I can talk about, and I'll look and make sure that there's nothing in the chat that I need to respond to. But it's really just kind of a wrap-up thing. Let's go over to Canvas and make sure everybody sees what's over there. So, yep, that works. So we've got quiz 2. I just opened it up. Now, if you're graduating, it's really unclear right now. I've gotten 2 different messages from 2 different sources of when grades are due for graduating. So I will have to see which one's true. Just in case, I'm going to turn in graduating grades tomorrow. So if you're graduating, then don't worry about quiz 2. So I'll chat. Let's see. Is the distance measured off of where it finally rests? Or I was going to do like multiple. One of one category where this is where it landed. It landed exactly at 10 feet, but then it moved somewhere. And another category for it rolled. So I was going to do both. And like the winner for one of the idea in my original mind was that it would be where it landed and rolled. So where it finished up at. That would be the 10 feet. But yeah, I'm thought that, well, it also would be cool if you could just hit 10 feet exactly. So it'll be both. It'll be on grass, so it won't roll too much, but it will possibly bounce or something. So I'm going to actually have 2 categories. So there'll be a winner for hitting 10 feet and a winner for rolling to 10 feet or bouncing or however it got there. So both. Let's see. What was I saying? Oh, yeah. Grades. So if you are graduating this quarter, then one of the sources told me that grades are due tomorrow. So don't worry about doing quiz 2 if you're graduating this quarter, unless you've already done it, which I don't think so because I just opened it like a few minutes ago. So unless you were really on the ball, you probably haven't done it. Anybody else that's graduating sometime later, like the fall or the winter or next year or whatever, yes, quiz 2 is open, and it stays open until Thursday night. That's the end of the quarter. Quiz 3 here, you won't be able to see this quiz. This one's hidden, so that's not it. It's the one that you can actually see on class 30 called quiz 2. This one everyone does, but it is just a end of course survey kind of thing. So it's not the one from the university. I actually don't even think we do them from the university during the summer. This one is my own. So it's things that we've been doing this class for, I don't know, maybe 10 years or something. It's been a long time. And so it's definitely changed over the years as far as we used to scratch build printers because you couldn't go buy a printer at all. So that just wasn't a thing. So you had to build your own, and we used to do that. And over the years, it's kind of, that's not the focus anymore. And so this end of course survey, it says course assessment quiz, and I name it quiz 3, so I give you credit for doing it. But you can't get it wrong. You just can, I guess, if you didn't do it. But that one gives me some information on like new things to do. So add in resin printing or whatever the new things are. So fill that in. Also, I should make it where that closes on Thursday. I don't think I did that. Let me fix that real quick. Actually, it doesn't close at all. So let's make that close. There we go. Now it'll give you a due date on that, or a closing date anyway. Let's see. The rest of it is way back up at the top. Turn in the assignments here, and I will go through those and grade them. Most all of them are you did them with some level of effort and you're okay. The quizzes, those I grade, because they're questions. And then the benchy, I grade a little bit more like, hey, you had some overhangs or some Z-seam that was really bad or whatever the thing is. They still end up generally pretty good grades. The others, the optional assignments, those are you did them and you didn't just put minimal effort. You did something. So generally you do okay on everything. It's really hard not to do decently well in the class unless you just don't do stuff. All right. So I think we answered our question over there. Haven't seen any others. Let me see. I thought what we could do is talk a little bit, and I'll answer any questions that pop up over there that I can. Talk, what is next for 3D printing? So there's a couple of, and I'm more or less thinking of FDM 3D printing. There are other types of 3D printing that are being investigated. Obviously there's metal 3D printing, and there's the resin, the polymer, liquid polymer type of printing, and those actually they're older than FDM printing. So, or at least the liquid polymer resin type stuff is. Those they're carrying on. The big hindrance to those is with the resin, the liquid resin is the mess. So you've got to figure out how you're going to deal with the messy part. And wash and cure stations are becoming more common, even at the industrial level. They're trying to automate some of that that side of stuff. Those will keep carrying on. Metal, the big problem is just the cost of it. It's really expensive to do, or to have the machines to do, and it's really limited to higher end applications. We aren't yet going to have little metal 3D printers in our homes. Not to say that we won't ever, but it's still a ways off. So that leaves us with the FDM. There is a little bit of research. So all the plastics that we've been doing are, I can't think of the word now, thermoplastics. They're thermoplastics versus thermosets. And the reason being that you can melt a thermoplastic, you can form it into a thing, and it cools down and it stays, and it melts, not the right word. You can, soften it, and it'll hold its shape, and you could redo that a couple of times. But thermosets, you put them together however you create the thermoset, and once it sets, that's it. You can't really undo it. You can't reverse the process. You can't just heat it back up or whatever. And there are a little bit of research areas on the thermoset because they have some different properties that thermoplastics don't have. For one, they are very heat resistant, and so that could be beneficial. You can't extrude them the same way that you can extrude a piece of PLA or ABS or something like that. So there's a little bit of research in there. That's probably not something that's coming to the home 3D printer, the consumer level 3D printer. I think the two big things that are next for consumer level 3D printers are things like this, and this is already here. I'm not necessarily advertising for SnapMaker here. They're just the most recent one to submit one of these options. There are others. There's a Prusa that has this, and then there's a I can't remember what the E3D maybe. There's another one, but the tool changer based printers where you've got multiple filaments. So this one has 4, and they each have their own filament path. They don't share a filament path other than the nozzle. Well, no, even that's not the same. They don't share the filament path at all. So it's not like the Bamboo Lab that has the AMS, where they all end up coming out of the same nozzle. Each one of these has their own independent nozzle. This guy, this is a Kickstarter and all that. Snapmaker is an established company, and I have used some of their printers. I have one in my other office at school, and it's a good printer. It's built well. The one that I have is older. It's much older, and it's really slow because it's several years old now, maybe in the 5 or 6 year range. So it's a slower printer. Now this one is I'm just looking at, this isn't even a real thing. This is a render, I assume. And it's a Core XY type printer like the Bamboo Lab, and like most of the newer printers are becoming now, at least the box kind, the enclosed kind are this, where the motion system is pretty fast and you don't have to move the bed back and forth. It's not a bed slinger. The bed does move up and down on this particular one, and on a lot of the ones that this form factor, most of them move the bed up and down. There are some where the bed is completely stationary and everything moves around it. And that has its advantages and disadvantages. But the price on this one, so this is a 4-speed tool changer. So what that means is, let's see if it shows any kind of, well, let's see. Well, there's kind of, well, let's see what happens if we play. Let's do without the sound though. They've got, here it is. It's docked one tool. It grabbed another tool. Now, automatic tool changing is not a new thing. It is in 3D printing, but in CNC milling and machining, it's a pretty old thing. It's not really new at all to imagine a mill that goes and changes out the mill that it's using to cut away whatever part it's doing. It needs a larger mill or a facing bit or something like that. And it changes it automatically. That's nothing new. How do I get back? I don't know how to close. Is this close it? Nope. How do I? Oh, I just click. This tool changing in 3D printing though is relatively new. Like I said, there's only a couple of printers, 2 others that I can think of. And there's some big benefits to it versus the other way of changing filament. So we did a filament change where we went and paused the print, took the filament out, put new filament in, and made a stacked filament change. It was printing one color for one layer, and then the next layer it was printing another color. We got some really cool results. We did this. Where'd it go? This kind of thing could be done with that stacking layers of filament on top of other layers. You could do this. And we did some token type of things. I think I made a Saints logo. And so you can do some interesting things, including relatively detailed stuff. But that was time consuming because you've got to change filaments back and forth. Now this one, any of these where you're just stacking filament on top of one another, you let it print however many layers of the first color, and then you change out for the second color, print however many layers. So that's not too many filament changes. But another thing that's becoming popular, which I guess I don't have an example of really handy, I should have brought one, but is more like the AMS system, where it's an automatic material changing. Let's go back to that one. System where there's a multiple rolls. Most of those AMS systems have 4 rolls on them, and the machine will do the filament swapping for you. So the good side to that is you don't have to sit around and wait for the filament to be ready to change. And now that it automatically does it, you can, in the same layer, you could imagine changing filament. You wouldn't want to do that by hand. You wouldn't want to print one color on a layer, change filament, print another color on that layer. That would be a manual process, or that would be really time consuming. The downside is, they had a picture, I even saw it when we scrolled by. The downside is, I think it's something in here that, let's see if we can find it. These are all multicolor prints. I thought I saw, a, oh, here we go. This on the right hand side, same exact print. You know, they look pretty much identical now. Obviously, they have selected good prints and all that kind of stuff. But the left hand side is with a tool changer. You still have a purge block because just like we did last time on our printer where we wanted to, we wrote the G code for a line of purge because you want the nozzle to be ready to print as soon as you ask it to print. You don't want it to have to get filament all the way to the nozzle, get it flowing right and everything. You don't want all of that every time on a layer. So you do have a purge block. But on those ones where you are using the same nozzle and feeding different filaments into it that are different colors, you have a purge of the old filament. You got to get the old filament out, then get the new filament in, then purge to the new filament so it's flowing well. So all of this, all these little gibbles here were the purging the old filament out so that you didn't mix colors. And so you end up with the same print in the end, but you ended up with purge blocks on both of them. Now this one they made a larger looking purge block, but I don't think that's really the point. This is the main point, is that the tool changer kind, you don't have all of this. The other cool thing with the tool changer is you might want to print filaments that have pretty different printing profiles. Maybe one needs a hardened nozzle, one does not. Although maybe that would still be a problem, not sure. But one is one temperature and one is a different temperature. That would be a better example. I'm not sure if you would get away with printing a hardened nozzle and then switching to another one. You'd still be grinding across the top of that abrasive printed filament. So I don't know if that would work or not. But you don't have the worry about heating up and cooling down two different filament temperatures. So that's another benefit to it. Here they're just talking about some of their AI type of stuff, fixing some of the corners and all that kind of stuff. Those are relatively well established things that happen in 3D printing already. But I think this is a new thing that we'll start to see more of. I originally thought that multicolor 3D printing wasn't that big of a deal. It's not that big of a draw, but I'm starting to think that maybe it is, because it's better than it seems like. Once you can push the button and it happens, then, and you don't have to sit there and change filaments and all that, then you start to do more of it. You start to use more of the multicolor stuff. Obviously, it creates new things that can fail. Now you have 4 filament paths that can fail, so you do have to deal with that. Let's see. Been meaning to ask this. I printed a life-size sword. Would that fall? Oh, or this is a different question. Would that fall in? Oh yeah, sure. It could be either one. So if it's life-size, then it's definitely the large print. If it's a one that fits into any kind of cosplay, then it could go into that category too. So yes, I think that fits into 2 different categories at least, if not more. And it's probably also a multi-part model, so it's probably one of the assembly categories too. So yeah, and it's okay to count one thing in multiple categories, particularly something that probably took a long time to print and a long time to finish and all that kind of stuff. Then it can count in multiple categories. So this is one thing that I think is coming, and it will be more popular, is the tool changer type of multicolor and multi-material printing. And the price on this one, now this is their Kickstarter thing, so their suggested retail price is $1,000. So that's a lot for a consumer, but I could definitely see people going this route if they were more established. Maybe not as your first printer. I'm interested to see how the SnapMaker does, because their original idea, why it's called SnapMaker, is that it was a single printer that you manually unbolted and rebolted on a new head, and it had 3. It had the print head, it had a laser head and it had a CNC milling, like a little router. That was their original mindset. Now, are they going to? This one is just printing. All four heads here, all four tools are just printing. But are they going to make some of these modules that are laser and CNC? I don't. They could do the laser, so you could imagine one of these little cartridges being a laser. You couldn't imagine one of them being a CNC mill, like a router. At least not in this current factor. It's just connected to weak. It's not. You have a pretty heavy side load on a CNC mill, and so you need a really secure system of attaching that to your motion system. And right now, it looks like they're mainly just using magnets, which laser, there's no side load on a laser, so I think you could do that. Obviously, printing, there's very little side load on that. And then CNC milling is not going to work in this particular setting, but is it something they're working on? I'm sure. I don't know that it ever really makes a lot of sense to have one machine where you have all three of those things happening, because of the debris. Like if you're milling, you generate a lot of dust or a lot of whatever you're cutting away, and if you're lasering, there's soot and all that kind of stuff. But if you're lasering in a chamber where you just milled a bunch of stuff and there's sawdust, I think it's just too risky to put all those together without some really thinking about how the evacuation of the residual works. So I don't know if they're gonna anytime soon have one machine that does all of these things seamlessly, without some pretty major steps in between them. I could imagine one that does lasering and printing. I can imagine that. Still doesn't make a whole lot of sense, but it kind of makes sense in the idea that you're maybe a small business or a small consumer that manages to get $1,000 to spend on a printer, and you could have a laser and a printer in the same footprint. So that would be a benefit. It doesn't take up 2 machine spots. I don't know about the CNC part. Let's see. I haven't had a chance to do the finishing part. Oh, yeah, okay. Yes, I would imagine that that's at least going to be 2 things. So maybe it's not finished. So there is another category for finishing something, as in painting and all that kind of finishing. So yes, at least 2 on the large side and the assembly part and the cosplay. So maybe 3. Depends on what other prints you have too. If you have others that would work better. So this is one thing I think is going to increasingly happen, is the tool changer side. The other thing, and I don't know where this one's going to go, but it's on the AI. Now, even this one, if we scroll down somewhere, there it is. There are some AI detectors that are trying to tell you that something happened. Here, their purge block fell over. They had a spaghetti failure somewhere right there, and so it first layer didn't adhere right. Stuff like that. There are already built in. The problem, well, I guess it works, but my problem with them is that those rely on a cloud connection, so they aren't local for the most part. I haven't seen any that are local, and so I don't really like that as the long-term solution, because it does require something somewhere to constantly be monitoring a video feed from your printer, and so that's a lot of data. That's a lot of security. Where's this connection going to and coming from, and all that kind of thing. So I don't know that that's the best way to do it, but it's not done locally because of the processing power currently. Those papers I showed you, maybe that was last week sometime. That's some of the stuff there is talking about how can you do that fault detection locally in real time without massive computing power behind it. Something like a Raspberry Pi. All right, so I think that's already out there. That's happening, but on the modeling side, there's more and more. I went to Thingiverse this morning. Let's close that. Went to Thingiverse this morning, and this one, this one. So those 3 on the front page. I just typed Thingiverse. This is the first ones it gave me, and there's one ad. So 3 of these are AI generated, and one of them's more of a functional print, but it says it's AI generated. Um, I think that's something that will start to increase um, pretty heavily. So the ability to AI generate, this one's actually doesn't look very fancy or anything, but if it really did generate this from AI, that's actually pretty impressive. Um, Now, was it AI assisted? Probably more than likely it was AI assisted, but I don't know. It shows some threads in here, your little pockets, and it's going to water them. I don't know what the red orange thing is doing, if it's actually just decoration or what. I wonder if they say, doesn't really say uh, where the AI came into this one. So, at least not in the summary. So, if AI is generating this with the screw threads that match a water bottle and the pattern and the insert and everything, that's pretty impressive for AI CAD modeling. These are more normal, where it's more organic. You know, a giraffe with a knit pattern on it sitting. You could imagine that prompt pretty easily. And this one is multicolor, but see what they did is the eyes are separate. So that's always an option, right? So I think there's some AI on the generation side that will begin to show up more and more. I don't think we're at a point, if you don't count the generative topology, topology optimization, and generative design from SolidWorks and Fusion. If you don't count that as AI, which I don't, it doesn't really fall in the same. It's not generative AI, although it's literally called generative design in Fusion. It's using a process of you know, finite element analysis, simulation of the stresses. Then it selectively chews away at the unstressed parts and reruns the finite element analysis. I guess that is some on the AI category. It's not the you gave it a prompt and it just generated it though. So you had to give it some structure to work with and some goals, which I guess is kind of how AI works. But I'm thinking of more the Chat GPTs and the Claudes and those sort of things, where or the Meshy.ai, where you give it a picture or a prompt and tell it to generate the thing. These are pretty easy to do now with even some of the free generative AI model makers. The Okay, I think we're back now. So all I was saying is I don't know how you get the AI label if you self-select it, or if somehow it's thinking this is clearly a render, and so maybe it thinks that it's AI. I don't know where the AI label comes from on these things on Thingiverse. All right, we keep getting disconnected here, so I don't know if it keeps disconnecting. Then maybe we'll just call it a day, but we'll give it another chance. It actually hasn't. There it goes. So if it disconnects again, I probably will just say that's enough for today. So I was looking for, are there some other AI generated? Here's one. That again, though, that looks like something that would be AI. I was wondering if there were more of the stuff that looks like it came from a real CAD package. Don't really see anything. So I think those are two of the things that are going to affect home consumer level FDM printing, is the ability to go to a tool like Meshy.ai, type in a prompt, get something that is printable. You know, you could that's probably actually AI, even though it's not labeled as AI. Here's one that's labeled as AI. So get something that it's not going to be necessarily currently designed specifically for 3D printing, but if you combine that with your tool changer and your multi-material, you don't have to worry so much. In fact, there was one of these, I saw this one. So what they're doing here is they've built, a bridge, and all of this kind of yellowish clear material, that's a dissolvable support material. That's probably PVA. And so what you do here is you've got a really delicate print that needs a lot of support, and you could go and support it like this guy with the tree support or whatever and peel the support away. But if it's not robust enough, if the actual part is wimpy in any way, then it's going to break. But with this stuff, you put it in water or whatever dissolves it. The most popular one right now is a PVA, so it's like Scoop, the Elmer's white glue. That's PVA, but in filament form. And you dissolve it away in water, and you're left with your part without having to like manually pick all the support material out. And if you have a multi nozzle or some way to switch filaments, then this stuff starts to become a lot easier to do. The support, you're still wasting the support. You don't get the a benefit from having the support, but now all of these AI things with that are going to not necessarily be designed for printing. The AI is not necessarily thinking about overhangs and bridging and all that kind of stuff, at least not yet. And so, but it makes it really easy to print whatever it did generate. So the combination of those two together will start to generate more and more options on things to print. People making models and or using AI assistants to start the model, and then you finish it out, will still, for the time being at least, generate better models and things that will work better. But with the combination of tool changers and with AI not really caring about the overhangs and printability, you'll start to see more and more, I think, you'll start to see more and more things that are being printed, FDM printed, even though they may not have been that easy to print, because now it doesn't matter that much. The very first printer I had, in 2002 or 3, something like that, it did this. It had 2 nozzles, and one of them was for support, and the other one was for the filament, the actual model. It was not multicolor. You couldn't do anything other than that. The other nozzle had to be support material, and it didn't dissolve in water, so it dissolved in a little bit harsher chemical. But that idea has been around a long time, and making it easier and easier for a consumer to do that same idea seems like the current direction things are going. Now this one has 4 paths, so you can imagine 4 different colors. You can imagine one of them being the support in 3 different colors or whatever. I think the E3D version of this, or maybe the Prusa version, has 5 tools that you can change. So just the more tools you have, the more materials and colors you can use simultaneously. Okay, what else? Let's see. I'll go through really quickly some of the other printer types that we didn't really cover, but they are out there and you can at least know that they exist. One of them is the Mark Forged type of printer. So these are higher end. The cheap version of these are $20,000 or whatever. But let's see if I can find some of the... They do have a metal printing one that is cheaper, but it's still, I don't know, the whole system is $70,000 or something like that. And this is a filament based system where it prints a really heavy metal content filament, and then you have to center it and create a solid, melt away all of the filament part. Whoops. But the one I actually wanted to show you was, I think, this one. Yeah, so this one, we have one of these in Bogard, and what it does is it prints a carbon fiber nylon, so nylon filament with carbon fiber chopped up into it, or just plain nylon or whatever. And the special, that's pretty cool by itself, printing carbon fiber nylon. Nylon is harder to print. it is printable. I've even printed it on a modified, but a regular Ender 3 that put in a hotter. It prints hotter, so you had to put an all metal hot end and then put in an enclosure. And I was able to print nylon. It didn't work great, but it was able to print it. So that's interesting. But the real interesting part on this one is this little spool in the background. What this printer does is it will print a layer of your whatever filament, carbon fiber, nylon, and then it can lay in continuous strands of Kevlar or fiberglass or carbon fiber like thread. And so embedded in your print, now it's still layer by layer. It can't do a z-axis movement for the threading of the continuous fiber, but it can inlay continuous fibers of those three materials. And maybe there's other. Those are the three I can remember: fiberglass, Kevlar, and carbon fiber threads. And so what that does is it really greatly increases the strength of the material, because now the tension, if you're trying to bend this thing, the tension's being carried in continuous fibers. It's not in the whatever you extruded. It's in threads of Kevlar or fiberglass or carbon fiber. And these are not crazy expensive. You still wouldn't probably own one as a consumer. But a small business, you could imagine owning one of these. They're in the $20,000 to $30,000 range. They don't need any post processing or anything. There's no, it's all FDM printing, other than the fact that they do have a mechanism in here that lays in continuous threads of that reinforcement material. I'm just going to see if I could find kind of a picture. It doesn't really have a picture of it happening, but it's continuous fiber reinforcement. So that's one printer that if you're trying to make functional, strong parts, first of all, the carbon fiber nylon by itself is pretty strong. They call it onyx is their name for that. But nylon by itself with nothing in it is a little bit on the rubbery side. It's it's not rigid, but you put the carbon fiber, the chopped carbon fiber in there, and it becomes rigid. And then you put the continuous carbon fiber threads, and it becomes very rigid. Now it still has layer by layer issues. You still would have a weak shear direction across the layers, parallel to the layers. That's still, nothing's really happening there. But this is one way to make some really, really strong parts. And it's still in the FDM category of printers. Another one, and these have kind of, yeah, there's one. They made a big hit 2 years ago or so, and then kind of haven't really done much. And I think there's the reason why. So let me try and get to one of these so you can see it. The reasons why. So these are the belt printers. They are still limited by the speed of the belt slinger type of printer. The only difference here is the bed is actually a conveyor belt. So the good side is once you get these set up, they do print awkwardly because they are printing on a 45-degree angle here. Like the print head runs up and down this rail in the back. So they have a little bit of awkward motion system. The good thing is they have an infinite, whichever direction you want to call that, they call it the Z, but infinite Z direction. And you can just print, part after part after part, the same part after the same part, or a really long part like a sword or whatever, all in one piece. And it just rolls off the back of your conveyor belt. I think the downsides to these are that they're kind of expensive. Like this one was $1,000. They don't print as well. Like the print quality is not as good as the regular Cartesian coordinate system. The orthogonal printers. They don't print fast, so they don't have the advantage of fast. The only advantage that I see that they have is that you could do large batch prints. Just part after part after part. So if you're printing the same set of parts over and over again, this might be a way to do it, if you're willing to just let it sit there and print all day, all night, and just crank out parts. But I think what people have decided seems like I just rather would have, 3 or 4 really fast printers, that are printing parts 5 times faster than this thing can print one part, and I'll just print them in small batches over and over and over again. And that seems to be what most people end up doing. But this is a thing. There you can kind of see their idea. It's got a take up level over here where you can just roll parts off of it. We do have one. We print with it occasionally, but I don't know. It's not ideal because it is slow, and it is a weird motion system that takes a little bit to tune. But you can get really long single part prints off of it. Kind of expensive for what it is, though. There's really no reason it should cost this. It should cost in the same price range. The conveyor belt itself, and I guess that those rollers are not cheap, and so that's probably where some of the extra cost is coming from. But they should be half that price, really, and then you might get a little more adoption on those. So that is out there. Probably not going to take off, I don't think. I think people are just going to do the faster printers and more of them, is what I would do. Let's see, what else is out there in the FDM printing that we haven't talked about? There are other types of printing outside of FDM and resin, and we haven't really talked about a lot of those because they're not very mainstream. I guess we mentioned the metal printing, but there are some other printing. There are some that use a powder. So, whoops, got to type in the right word. Let's see if we can find is this one going to be one? No. Trying to find some of the actual. Well, all right. So this does remind me. They won't show me any of the actual prints, but so there are some powder-based printers. Best you get is looking into the chamber here, but I don't see any that show me any of the prints. So what these do is there's two big kinds. One is the selective laser sintering, this SLS right here, and it uses a high power laser. Oh, here's some prints. And a bed of powder. So usually this powder is nylon, although it can be other materials, and it will melt together the powder particles with the laser. So it's like the same thing in the metal printing that uses the same process, except the powder is metal. Here the powder is some kind of polymer. A lot of times it is. I was looking to see if they had polymer material. Oh, okay. They named them. They're usually a nylon-based a nylon-based material. These are not telling me what the actual material is. It's just, oh, this one's flame retardant. There you can kind of see in the back. Well, there it is. In the background over here, there's some of the powder. These, they have one big benefit. Well, they have two big benefits. One of them is they are generally pretty strong because they're fused to one piece, so you get pretty much the bulk material properties. The other benefit is they don't need support because they're printed in a bed of powder. So the powder itself, the unsintered powder, is the support. So you do have to. I was seeing if they had a picture of excavating one of these, but basically the little box they end up printed in, you have to dig out your part because most of it is just uncured or unsintered powder. It doesn't cure, it melts together, and then you take your part out. So there's a little bit of cleanup on getting all the unsintered powder off of it, and it's very small particles, so there's dust and that sort of stuff. But these are, highly detailed, highly that you don't have to think so much about how is it going to be supported, because the powder itself supports it. So these are a different type of printer, generally pretty expensive. And I just happened to pick on the flame retardant one, but there are more reasonable, like just regular nylons or whatever, um, biocompatible, ductile, flame retardant, a flexible one. I think I did bring a flexible one time early on, and it was a little looked like a rook, like a chess piece, but it was flexible. It was this kind of stuff. High performance, so high strength, toughness, multi-purpose. I don't know what that is, but it's basically just a nylon. And so this again is more industrial. If you need this kind of stuff, this is the kind of thing that you could go to a place like Xometry or one of the online prototyping websites, and they usually have this as an option for printing. Some kind of SLS, so selective laser sintering, and it's a powder based, so it's not as messy and all that. It's still messy because you have powder everywhere, but it's not gooey and liquid resin messy. And you get functional parts. This does get used to make actual end products in some industries. Some of the some automotive, some of the plastic pieces there are made in this kind of format. So let's see. So that's out there. And there's not really a consumer level version of this. The closest is the one that I had showed you a sample of, and it is I don't know. I'm trying to think of the price. I think it's in the $30,000 range, somewhere in that range, somewhere around there, and that's the cheap version. I think the cheapest of these that I remember is the Lisa. Let's see if I can find it. I don't see it right now. Oh, here it is. The Lisa X. This is the cheapest version, but it's still going to be in the $30,000 range, or somewhere in that range. It probably depends on the size that you're getting and that sort of thing. I was trying to see if they showed, there's some of the parts that they've made. So you can get high fidelity, lots of thin pieces, in the whatever you would call those little spokes there, pretty thin, high resolution. This one is 1/2 inch per hour, so that's kind of slow, but fast for this kind of machine. All of these are not, well, no, there's a polypropylene. Most of these are nylon based, and then a couple of other materials here. But so that's one option. There's kind of a diagram of what's happening. You've got it's got the Galvo. So you got a laser system where it shines onto a mirror that's controlled to reposition where the laser goes and centers your powder together. Now, let's see, what are we telling me here? Oh, that's the cost per average part, I think. So, I think that's what that is. I thought that was the price of the base material, but that's for a individual part. But, if you're printing something the size of a knee, everybody knows how big a knee is. You can print it for, depending on what material you use, these are euros, so you'd have to convert, but 70 euros, 107 euros, so not crazy prices, not the same as PLA and ABS though. So that's another one of the printers that's out there. The big categories of printers, the SLS. I don't know that it will also come to consumer level anytime soon, because it is, it's a system that doesn't lend itself to being in somebody's home very easily. So because you have to deal with all of the powder. But if you're interested in something at the lower end price wise, this Lisa printer is probably on the lowest end of the powder based printers. And the other thing about it is that this open here means it's very flexible, and you can do things with it that you can't do. It doesn't use proprietary powders and that kind of stuff. Some of them are very locked into their ecosystem. All right, I think that's probably a good stopping point. There are printers that I saw one probably 25 years ago or so that it would cut out sheets of paper and glue them together. That one didn't take off, but there's all sorts of little experimental types of printers out there. And I think these are some of the bigger things that are happening, particularly the multi-tool, the tool changer kind of printer. I think that's for consumers is probably the next bigger iteration of things that are happening. If you can get that type of printer down in the sub $1,000 range, consumers will buy that, and I think that's probably where things are next going to iterate. We've been through kind of the most all of these new printers are now running the higher speed motion systems. They're Core XY. They're running the little bit of kind of baby AI, trying to do some things like the input shaping and maybe some first layer quality inspection, some flow rate inspection. I can send a print to the Bamboo printer right now, and it will print out a test print for flow calibration. It will print the first layer and observe it with a camera and see if it is stuck down well. And periodically throughout the print, it will check to see if there are any loose threads or whatever, loose filament threads that make it think that it's failing to adhere. Yes, there are metal printers. They're just not really consumer level yet. But yes, and they're not even really anything outside of research and industrial level. They're just so expensive for the real metal printers. Now there's the metal printers that do the sintering kind, where you print a FDM strand of filament. It's mostly metal, and then you melt out the plastic and sinter the remaining metal into a solid piece. That's just really hard to do. That's what those Metal X printers do. And we did mention this one a couple of it's been a couple of weeks, but if you really wanted to try it, go to Virtual Foundry and get you one of these starter kits. It's not crazy, but it's not cheap either. Like there's a starter bundle, $500, and if you really were like, I've got to figure out the metal at home printing, this is what you could do. And $500, it gets you a little spool of one of you can choose different, like copper and a couple of stainless, and I don't remember what the others are. I think maybe there's a brass or something. Get a little bit of that filament and all of the parts, the crucible and all that kind of stuff that you need to do the sintering part of your print. The downside to this is the biggest hurt. You can get that far. At some point you have to figure out the sintering. And so that means you have to have a furnace capable of getting to like 1500 degrees or something. So that's the limiting bottleneck on most of these is, your oven is not going to do that. So you've got to have access to something like a kiln or a real furnace. And if you have access to that, then you can at home at least try some metal printing. It's still very hard to do, and you get some results, but you have to have that furnace. You have to have that is the biggest limiting thing. It's even hard to print this material on an FDM printer, but it is printable on a Ender 3 or whatever. I wouldn't print it on one of my nicer printers. I would print it on one that I was kind of my experimental printer, because there is a good chance that the nozzle, the hot end, is going to have to be replaced after printing this stuff. Maybe not, but probably so. So there is a way at home to do it, but you have to have access to a really high temperature furnace. All right, I will see y'all, or whoever shows up Wednesday. I'll see y'all. Everybody else, there's no more streams. There are just things to do in the quiz 2. Stays up until Thursday. So does quiz 3. Quiz 3 is just a course assessment, so you can't get it wrong. There are actual questions. I think there are 20 questions in quiz 2. You may have to look up some of them. Some of them are things we mentioned but didn't really go into a lot of detail about. So you may have to look up the answers to that. And then quiz 3 is just your opinion on things. So you can just write in whatever you think. And then, like I said, if you're graduating this quarter in the summer, then don't worry about quiz 2. I'll go ahead and do quiz 3. I'd like that information, but don't worry about quiz 2. I think there's only one person that is graduating in the summer. All right, I will see whoever I see on Wednesday. We won't have any more of these streams. There's still some stuff we didn't get done. We didn't finish the X30. There's the canopy still needs to be printed. If I print that, maybe I'll throw a little video just so you can see how it ended up. I just haven't had a chance to print it yet. And we've got there's several of those time-class filaments we didn't try out. We tried the soap one, but I still have a bouncy, and I have a fish bait one. So I want to try those out. Oh, thank you. It's fun to do this class anyway. So I like doing it. It keeps me up to date on what's going on too. Particularly fill out this quiz 3 assessment thing so that I get some new ideas for. I should teach this again in the winter in person, and then next summer, probably the same thing, just different topics. And so if you're interested, you can probably watch it again next summer with new content, up to date. All right, I will see y'all